Guys, today we are back with a very exciting problem, and today's problem is basically all about a hard problem, a lead code level hard, and which has an accuracy of 48%. Till now, what we can see, there is 30,000 plus submissions as of today, and the points which we will given today is 8 points, and this is a pretty hard problem. It only honestly took me around say an hour or so to complete this entire problem. So first, I'm going to break down this problem into multiple points and multiple parts so that you can understand it very clearly. What we are going to do is we are going to count pairs in a particular array. So in order to count pairs in a particular array, this array is basically giving a question such as the size of the array is given as 4. So if the size of the array is 4 and the elements which you are taken in the runtime input are 8, 4, 2 and 1, it is saying the output is 2. So how do you calculate this operation? First, I am going to show you the rough calculation, and I have made a template in order to make the understanding of this problem very easy and in an efficient manner. So what we can see is we are going to give an explanation to this hard problem. First, we are going to do the operations. So what we are going to do is we are going to make a sub array and do the operations. So what operations we are going to do is, first what we can see is there are four elements, right? So we are going to multiply the index of each element, because in the question it is given over here in the question clearly that it is such that I into error of I is greater than j into error of j. This is the end goal. Right now we do not have to focus on the end goal, we have to focus on the primary or the starting part. So the starting part is saying that I into that particular element, right? So I is basically the index 0 into 8. I is for the second index it is 1 into 4, and so on. So when we store the multiplication into a second array, which is a resultant array, the resultant array output will be 0441. As you can see in the question as well, the resultant array output is over here 0441. So this is coming by multiplying the index of each individual element with that particular array elements. Now what we are going to choose is we are going to take the combination of elements in this particular array such that the first element is greater than the next adjacent element. So this has to be calculated using divide and conquer approach and a merge sort algorithm. So divide and conquer approach and merge sort algorithm will be explained further. First, what we are going to do is we are going to check which element is greater than the next adjacent element. So in this 0443, first pair is 0 comma 4. Is 0 greater than 4? No, 0 is not definitely greater than 4. So what we are going to take is 4 is greater than 3. So our pair number 1 will be 4 comma 3, and our pair number 2 will be also 4 comma 3, because there are two 4s present, right? Next, what we are going to do is we are going to return the total number of count. So again, you can say I'm writing 4 comma 1 and 2 comma 1. How is this 4 comma 1 and 2 comma 1 is coming? So basically what we can see is whenever we are checking what is the particular position of 4 comma 3 or the derived output, in the derived output 4 comma 3 is the valid pairs. So if a pair is valid, which is 4 comma 3 and 4 comma 3, 4 is over here and over here 4 is there, right? And 4 comma 3 is basically signifying the pairs which are corresponding to the original pairs in the given matrix. So 4 is this one, right? And 3 is denoting the element. So 4 comma 3 is coming like this, 1 into 4. So in one position what element we have? 4. And in the second position we have 3, right? So in the third position which we have 0 1 2 3, which is 1. Similarly, the output can be 4 comma 1 like this, and the output can be also 2 comma 1, because 4 comma 3 also signifies this particular position 2 comma 1. Now I hope you guys understood this particular problem. I will explain it through an example too. This will make it more clear. So in example 2, we can see, first I will see the question example 2. You can see that there is 7 elements, right? In ARR, there are 7 elements, 7 particular elements. We have to find total number of pairs which are fulfilling this condition where the index multiplied by the particular element is greater than the next index multiplied by the next particular element. So if you see in this particular question, the elements are 5010 to 416. Individually, I will write the indices like this: 0, 1, 2, 3, 4, 5, and 6. And then I will multiply the indices with the particular elements and form a resultant array. So the resultant array will be 0, 0, 2, 6, 15, 5, and 36. Now we're going to make the pairs which fulfill this particular condition. So the pairs which fulfill are 26. How 20 and 6? Because 20 is greater than 6. So the first element is greater than 6, then we will make it into a valid pair. So similarly, 16 is greater than 5, 20 is greater than 16, and 20 is greater than 5. So these are the four possible, like five possible pairs. There is also another pair, this one, which I haven't added. I will explain you. So these are the five possible pairs there are total, which fulfills this criteria. So in case of 26, how 10 comma 2 is coming, right? So you will ask this question, how 10 comma 2 is coming. So 20 basically means what? 10 into 2, right? And what is 6? 6 is basically what? 3 into 2, right? 3 into 2. So what 10 comma 6 is? 10 comma 6 is basically our 0 1 2 second position, and second position we have the element 10. So the valid pair is 10 comma again the 6. What is 6? 2 into 3. So in 2 into 3, what we can see, our element is 2, because in the third position we have the element 2. So the valid pair is 10 comma 2. In this way, the valid pair has to be calculated. Similarly, you can see for 10 comma 4. So what is 10 comma 4? What is 10 comma 4? So you can see in 10 comma 4 we are getting, we have to first calculate the valid pair as 10 comma 4. So if something is 10 comma 4, means this particular element and this particular element. So in the main array 10 and 4. So if something is main array में 10 and 4 है, so what 10 is basically signifying? 10 is basically signifying 2 into 10, right, which is 20. And 4 is basically signifying 4 into 4, which is 16. So when 20 comma 16, where 20 is greater than the element 16, we can write 10 comma 4 is a valid pair. So there is a particular logic. When you make this particular logic in your notebook, I'm pretty sure you would understand what is going on. So in order to solve this problem, we are going to solve this using divide and conquer approach of merge sort. So first I'm going to explain the merge sort in a very simple graphical manner. What we can see is there are random elements present in a particular array, right? So 12, 31, 25, 8, 32, 17, 40, and 42. These are the random elements present. According to the merge sort, we have to first divide the array into two equal halves. Then merge sort keeps dividing the list into equal parts until it cannot be further divided. So we have to basically divide and conquer. So we know that how you know, like if you see ancient history, the Britishers came into our country and they divided the country into three parts so that conquering for them becomes easier. So whenever you are getting a bigger array, we are dividing into subdividing into two smaller arrays. So you can see a big array is subdivided into two smaller arrays by dividing from the center or the half. So now the array becomes 12, 31, 25, 8, and the second half is 32, 17, 40, and 42. Now we are going to again divide it into two parts. So first there are four elements becoming divided into two elements, and then similarly it is divided into smaller children or smaller subarrays. Now what we can see is the subarray is created as the least subarray is 12, 25, 18, 32, etc. Now we are going to again divide it into such atomic value. What is atomic value? Atomic value is basically signifying, suppose we have two elements, we have to further divide it so that only one element is left and it cannot be even more divided. So like 12, 31 is further divided into 12 space 31, 25, 8, like this it is divided. And lastly, what we are going to do is we are going to merge the combined array. So whenever we are going to merge the combined array, it will become, see, 12 and 31. Whenever we are merging, we are going to use a technique so that we are automatically merging the value in ascending order. So you can see 12 and 31 is there. So 12 is automatically lesser than 31. So 12 and 31 is provided over here. Similarly, 8 and 25 is there. So 8 and 25 is also merged in ascending order. For 32 and 17, 17 is also merged in ascending order. and 40 and 42, it is also merged in ascending order. Lastly, when the elements are merged and then they are created into sub-arrays, in the next iteration of combining, we have to compare the arrays with two data values and merge into an array of found values in sorted order. So 12, 31, 8, 25. Now again we are going to sort between these two and it will become 8, 12, 25, 31. Again between these two, so it will become 17, 32, 40 and 42. When these things are finally sorted, what basically we can see, now we have two cities or two countries which is independently managed by two different arrays. Now these two arrays in the end will be further checked whether if element is mismatching or not. So you can see in the sorted order 31 is mismatching with 17. So what we are going to do is we are going to sort it by putting 17 in the front and 31 after 25, and you can see a final array is sorted. Now you will ask me why am I doing a merge sort. There are so many sorts like insertion sort, there is bubble sort, and there is heap sort. There's so many sorts. Why doing merge sort in this particular question? So in this particular question we have to apply divide and conquer, because right from the beginning we can see that array is subdivided into valid pairs. How will you find the valid pairs where the initial value is greater than the next adjacent value? In order to do that we have to do merge sort, so it clearly explains our concept of doing the merge sort. Lastly, I'm going to code for the merge sort. Before coding the merge sort and the particular program, I'm going to explain the algorithm of this program of the merge sort. We are going to do merge sort into two halves, right? So the first, like the explanation part is given over here. I will explain it while I code. And secondly, again you can see recursive methods are used in order to sort this. Now you will ask me where is recursion used. If you are new to this like concept, you can go and learn about recursion. For the time being I will explain you. See, whenever we are doing the merge sort we are breaking into sub arrays. Now the sub arrays are again joined to form another array. So this joining of this thing and again going back and continuously tracing back is calculated using recursive approach. So let's go with the problem statement. In the coding part we can see we have to take a class solution. We have given a method which will return an integer value and return the pairs. So in the coding what we are going to do is first we are going to like we will obviously check how this problem works, right? So we are going to give a function such as void pairs, void count pairs. So in count pairs, what we can see is we are going to take two arrays as our parameters. So int arr comma intn. So when two parameter arrays are being passed, we have to also take the util package, because we are going to import a lot of values over here. Java.util.star, java.util.star. Once the util package is also created, what we have to do next is we have to take the for loop and we have to take a result. So suppose our resultant array will be this. So this will be our resultant array, and I can write this as resultant array, which will initially give that particular thing 0441. So how 0441 we have to calculate? In order to calculate the 0441, we have to multiply it with the indices of the particular element. So what we are going to do next is we are going to take a loop over here. I equals to 0, I less than n, I plus plus, and then the loop is created, right? So when the loop is created, we have to initially multiply it and store it in the resulting array. So we can write resulting array equals to I into arr of I, because I is signifying the index and arr is signifying the particular position. So now we can print the resulting array int uh, I equals to 0, I less than n, I plus plus, system.out.println. Over here what I can print is res of I plus We can print the array like this. Now I have to create a main method in order to check whether this particular static void main string. So in this particular main method, I'm going to declare the scanner class on top of it. Sc equals to new scanner. So lead code hard problems usually take an hour or 45 minutes. If you are very good, it will take you on less than 30 minutes. So let's take the input system.out.println. We have to take the number of elements, enter the number. So what next we are going to do is we are going to basically check the question which we have completed over here. We have printed the array and now we are going to run the particular thing and check whether our question is performed or not. So whenever we are performing it, we can see there's missing a return statement. We have to make this as void method. So because void has no return type, so we have to again run it. So type void not allowed over here. ob.count pairs. Take a second. So for return res, public static void main count pairs. I've taken ob.count pairs. Yeah, I don't have to print it. Yeah. Now it will work. So whenever we are taking this, we have to be clear the number of elements. So, suppose the number of elements is 4 and the elements will be 8, 4, 2 and 1. So you can see the array is 0, 4, 4, 3, or this is our operation array. So what is the operation array? I have explained you in the beginning. The operation array is nothing but the array multiplied with the indices of this particular given array. So 0 into 8, 1 into 4, so it is 0, 4, 4, 3, and you can see the operation array being printed as 0, 4, 4, 3. Now what we are going to do is we are basically going to divide and conquer in order to find the valid pairs. So valid pairs, so using divide and conquer, find the valid pairs. So using divide and conquer, we have to find the valid pairs, right? So we are going to implement the merge sort, and in the merge sort, we have to return this as an int method. So we can write over here as static int count pairs, which will initially count and return the total number of valid pairs. So total number of valid pairs, we can write return return. We have to return this particular thing. So we can write merge sort of the resultant res, and 0 is the lower position and the upper bound is n minus 1, right? So we have completed the int method. Now the main part is the merge sort using divide and pair and tracking the count. So we can take the question and the code from over here, which we uploaded in this PDF. So you can see in my PDF, I have made a specific template for the merge sort. It will be easy for you to uh, s- just stop by and go through this PDF. So I have copied the code from over here, and then I will complete the merge sort. And now we are going to make the merge sort recursive method. So this is the recursive method which will call the merge sort method from the top. So just a second. So we have to execute it over here. So if you see, the merge sort methods are being created and the merge sort is also created over here. And what else is left? Yes, the explanation part is left, but I will explain it. Once I print the value system dot out dot println, since we don't have to show the array now again, what I can do is I can remove this particular print statement over here. So I will just turn off the comments over here and execute the rest of the code. So total number of elements is 4 and the elements are 8, 4, 2, 1, and the output is 2. If you want to check whether the output is correct or not, You can go over here and check there are total two pairs and the output is 2. For the second iteration, we can try the loop again with a new set of outputs. This time we have to put 7 and the elements are 5, 0, 10, 2, 4, 1, 6, and the output is 5. If we want to check the output is 5, we can check over here. The pairs which hold the condition true are, like over here there are 5 pairs and these are the total pairs which are holding the condition true. If you want to verify it, you can go over here and verify it from that uh, particular thing I have mentioned, which 5 pairs are being verified. Lastly, what I'm going to do is I'm going to execute this code on the GFG platform. So we'll be coming towards the end of the problem. We have to take this problem and go to the GFG platform, check our solution. We have to compile the solution. We don't have to make a driver method over here, so GFG doesn't allow us to make driver method. So I will cut this thing and then compile. So we don't have to even take the util packages because automatic packages are being taken for passing inputs. Class count pairs.java, no, we cannot take count pairs. We have to take the class as solution because in the driver the class is installed as the class solution. What else is there? Should be declared in a file name solution.java. We can over here class. Yeah, we have matched our submission. Let's submit the problem. Your submission limit has exhausted, please try after simply. Okay, so just submission limit has exhausted. Just let me check it once more. And just go over here, problem of the day. Submit this. You can see the test cases have started processing. So this was a hard problem and we have completed 63 days of this GFG, and now we are going to explain this code line by line by keeping it parallel to that PDF of mine. So where is this PDF? Yes.